In section 6.3, we're going to be learning about radian and degree measures. This section 6.3 we're going to cover in actually 3 parts, and the first part is what I'm covering here. We're going to be using a rotating ray to extend the definition of an angle to measure negative angles, angles greater than 180 degrees, and then of course your standard positive angles. Okay, so first of all, let's talk about angles. Angles, we all know what angles look like. They look like this, okay? And for every angle, there's an initial side and a terminal side, and you can see that better in this diagram that I have. You have your initial and your terminal side. That angle is said to be a rotating ray. So really what happens is this angle, to form this angle, is the bottom ray, which is your initial side, moves forward, sort of like the clock, the hands on a clock, forming your angle. And so the starting point of the ray is the initial side, okay? That's our initial side. And then the ending point, or the ending position, not the ending point, but the ending position is the terminal side. So you can think of it as like the hands on a clock moving and forming the angles. The end point of the ray is called the vertex of the angle. And an angle in standard position is going to be have its initial side on the positive x-axis. So you see here how this initial side is on the positive x-axis. That means that this angle is in standard form, as opposed to an angle that might start here, that being the initial, and this being the terminal. So this green angle would not be in standard position. Now, if the rotation of a ray is counterclockwise, then the angle is going to have a positive measure, and we can see that instance taking place here. So we think of that counterclockwise. And then if the rotation of the ray is clockwise, then the angle is going to have a negative measure here. Okay, so that started. So here you have your ray. And so if we want to be a positive, then that's here. And if we want that to be negative, and this would be my initial side, and my terminal side would be here, so that we're moving clockwise. So that one's negative, and this one is positive. And now let's talk a little more about the angles. An angle in standard position is said to lie in the quadrant in which the terminal side lies. So what that means is if this is in standard position, and it is, okay, because you can see that the initial side is starting on the positive x-axis, then if I ask you, if I call this angle A here, and I ask you where does angle A lie, you would say it lies in quadrant 1, and you answer that because that the terminal side of this angle lies in quadrant 1. Now, when it says in standard position, okay, so let's consider an angle maybe that starts, that being the initial side, the blue being the initial side, and the other blue being the terminal side, and let's say that is an 80-degree angle, okay? And I ask you, where does that angle lie? Well, you can't answer that based on this because it does not lie. It's not in standard position, okay? So in standard, when we talk about where the angle lies, we're referring to it from standard position. If we look at that from standard position, since 80 degrees is less than 90, we would know that that actually lies in the first quadrant, okay? And then a central angle of a circle is the angle whose vertex is at the center of the circle. So here you can see an example of a center of the circle. There's the vertex, and here's your angle. And this is going to become important as we get towards learning about the unit circle. So there we have a central angle. And now for our degree measures. An angle generated by one complete counterclockwise rotation has a 360-degree measure. And if it's a complete clockwise rotation, that's going to be a negative 360-degree rotation, okay? So let's just look at each one of those, okay? So let's say that I start out with an angle here, an initial side, and that angle goes all the way until it gets back to the same spot. Okay, that's going to be, since it came this direction, and you'll see the arrow noting which direction it's going, that one you can tell went counterclockwise, and so that's a 360-degree angle. On the other hand, we see this, our initial side moving in this direction back to its starting point. The arrow notes that it's moving clockwise this time, so that means that this one is going to be a negative 360-degree angle. So now we're going to look at several different examples of positive, negative, and angles that are greater than 360 degrees, mainly just so that you can recognize them if you're given a sketch, and that you would be able to give the correct degree measure. All right, so this first one, let's say I have something that looks like this. Now, if I'm just given this information, then I don't know whether the angle is positive or negative. What I have to have is some sort of notation, like what I'm going to do here in green, that tells me that I'm moving counterclockwise. So since I'm moving counterclockwise, I know I have a positive, and in each quadrant I have 90, so 90, 90, 90 is going to tell me that this is a positive 270-degree angle. Okay? So that's an example of a positive. Now let's look at an example of a negative. Let's say I have an angle starting in standard position, okay, and then here. So this angle lies in the second quadrant, and right now I'm not giving you enough information to, now I know. Now I know that this is going to be a negative angle measure. This angle is moving clockwise, and it's moving, I don't know exactly what that is, so I would have to give you some sort of information. But what this could be is negative 240 degrees. Okay. And later we're going to learn about coterminal angles, which would end up measuring this. So if I were to measure the angle from the positive direction, then I could figure the difference here, what would make the 360. So in other words, I would be looking for this piece here. And that's how I would find the positive angle measure there. All right, so we have a negative 240-degree angle. All right, and on our next one, let's say that, again, I'm starting in standard position. I'm going to end here, but this time this is the notation I see. Okay, with an arrow here. All right, so you can see that it is greater than, well, first of all, it's positive because it's moving clockwise, so we know it's positive. It's moving counterclockwise. Now we can see that it's greater than 360 degrees because it goes around, it rotates around more than one time. All right, let's go back and look at the very first one before we see. If we consider the first time that this touches, so if I'm looking right here, I'm going to use a black dot to show the first time that we touch our initial side, starting at 0, we notice that this doesn't quite make it around a whole time to touch it a second time, so it never gets to the 1, which means it's actually less than 360 degrees. Now if we move over here to this third example I have, let's say that first time it touches the initial side, it's at 0. The second time it touches it, it's at 1 times the 360 degrees, so we've got a 360 degrees, okay? And now it doesn't touch it a third time, but it does continue going, so what we have to do is figure out how far around this is. And what I would need to know is how far that is. We know it's greater than 270 degrees, so I would need to be given some sort of information there. But so let's say that that goes around, let's say that this is an example of a 660-degree angle measure, okay? And if that's the case, then this would be at 300, so this would be at 300 degrees. All right, so we get the initial 360 by this, and then the 300 would have to be given to us somehow. But here's an example of a 360 degree angle, or a 660 degree angle. Okay, again, that's your 0, 1, and then you count, you figure out what the degrees would be if it were lying in that third quadrant. All right, and now we're going to talk about our coterminal angles, and this will sort of help you understand the positive and negative angle measures a little bit more. So angles that have the same initial and terminal side are called coterminal angles. So for example, here, if this is my initial side here in red, and then this is my terminal side, if we move positive here in the positive direction, that's a 30-degree angle. But if we move around once and then come back and connect to it, that's going to be a 390-degree angle measure. Now it's a little easier to see if we look at it. This diagram here might not be the best. So let's look at it as initial, terminal. There's our 30-degree angle, okay? So the 390-degree angle measure should actually look, maybe this would be a better notation for it. Okay, so you can see that it goes around 0, 1, and then your 30 degrees. Okay, it goes 30 degrees past the first time it goes around. Okay, and then here we have an example of coterminal angle. So we have a negative example, and then we have a positive example. So the first example, and there are infinitely many coterminal angles within. So we've got your 30-degree angle, which is coterminal with the 390. And if you look at that closely, hopefully you can tell that the difference is 360. Okay, so if I go around another time, then I add 360 to the 390, and I can continue that forever. Now the same thing happens if I subtract 360 there. I again can find the negative coterminal angles with that. All right, so in the second situation, we have where we are moving this direction, okay, and that's our negative 90-degree angle. All right, now coterminal with that would be, what if we were to move from the initial side to the terminal side in the positive direction, going clockwise? Then of course that's going to be greater than the 90. You can tell that it moved further. So the distance it moved, or the degree that the initial side moved to get to the terminal side, is 270 degrees. So a 270-degree angle is going to be coterminal with a negative 90-degree angle. Those are the same. And if you do take the negative 90 and you add your 360 to it, you realize that you get your 270. Okay, and you could continue that and come up with an infinite number of coterminal angles there as well. Okay, so what we're going to do now is we're going to find 3 angles coterminal with an angle of 30 degrees in standard position. Okay, so I'm going to start out just by making my standard. This is going to be a 30-degree angle in each case here. Okay, and so here we go, and that's 30 degrees. Okay, so in each case here I have a 30-degree angle. All right, now let's find a negative coterminal angle first. Okay, so on this first example, you notice that I've moved to my 30 degrees here, and that is in the positive direction. So what if I were to actually go the other direction, clockwise? What degree would that be? Well, how far did I come from making the complete circle? I was 30 degrees from that. So and if you think of that being negative, so you could say, one way to do it is to say negative 360 plus the 30 is going to give us negative 330. Okay, so I was going negative 360, but I didn't get the 30 piece, so that added. Or if it's easier for you to understand by saying, okay, well, it's 360 minus the 30, and then turning around and making that negative, then you can do it that way as well, just by using the direction of the angle. All right, now the second one we have, let's come up with an example where we have greater than 360 degrees. Okay, so if we're going greater than 360 degrees, then let's say we start the first time and we want to move in a direction that is positive. So I'm going this way. I touch once, so go around, and then here I arrive at the angle. Um, so if that's the case, you can tell that I start, and from the initial side, I'm starting at 0 here, 0, 1, so that's my 360 there. And then how far beyond the 360 did I go? I went 30 beyond the 360, so that gives me 390. So a 390 degree angle there. Okay, and now let's do one more where we go beyond one rotation. Okay, so let's say I start here, I'm going in the positive direction. I come back to it once, I go past it, go past my terminal side, I come back to it a next time, and then I'm going to end here. Okay, so let's figure out how many rotations I made. So 0, 1, 2, so I've got 2 times the 360. And then I'm going to add to that how far did I go beyond the 360, and I went 30 beyond the 360. And I knew that initial angle measure is where I'm coming up with the 30 degrees. And so that is going to give me 750 degrees. Okay. And that's all I have for this first part of section 6.3.